Welcome to Astronomy Daily. I'm your host, Anna. Today, we've got some fascinating stories from the world of space exploration and astronomy. From SpaceX receiving the green light to fly their Falcon 9 rocket again after a recent mishap, to NASA's strategic crew adjustments on their SpaceX flights, there's a lot to cover. We're also diving into groundbreaking advancements with the Event Horizon Telescope that promise to reveal clearer images of black holes than ever before. And we'll take a closer look at how New Zealand's rapidly growing space sector is grappling with sustainability challenges. So let's dive right into the latest updates and breakthroughs. Fortunately, this didn't take long, given the potential problems, as we highlighted yesterday. The Federal Aviation Administration, FAA, has given the green light for SpaceX to restart its Falcon 9 launches following an investigation into a rare mishap earlier this week. A first-stage booster tipped over and exploded while attempting to land on a drone ship off the Florida coast. Despite this setback, the mission was deemed a success, as it successfully delivered 21 Starlink internet satellites into orbit. This incident marked the end of a streak lasting over 3 years with hundreds of successful booster landings. Landing the booster is usually a secondary objective for SpaceX, and no lives or public property were at risk. However, the mishap highlighted the crucial role of reusability in SpaceX's business model and the trust that both the U.S. government and private industry place in the Falcon 9 rocket. The FAA stated that the Falcon 9 could return to flight operations even as the investigation remains open, given that all other license requirements are met. Typically, the rocket's first stage fires its thrusters to achieve a precise upright landing. This webcast, however, showed it tilting and blowing up on the drone ship, a rare occurrence for SpaceX, which prides itself on its reusable rocket technology. The Falcon 9 was briefly grounded back in July due to a second-stage engine anomaly that caused another batch of Starlink satellites to burn up upon re-entry. Yet the quick resolution of these issues demonstrates the resilience and adaptability of SpaceX's engineering teams. As the workhorse of SpaceX's fleet, the Falcon 9 continues to be pivotal for missions involving satellite and astronaut deployments. Ultimately, this incident underscores the inherent risks and complexities of rocket science, but also showcases SpaceX's commitment to continuous improvement and innovation, ensuring the future of reusable rocket technology remains bright. Next up today, NASA has recently announced changes to its upcoming SpaceX Crew Dragon flight, marking a significant shift in astronaut assignments. Originally, the mission was set to include Crew 9 Commander Zena Cardman and veteran astronaut Stephanie Wilson. However, the agency has decided to reassign these two astronauts to make room for the crew from Boeing's Starliner capsule. This decision is part of NASA's broader strategy to ensure a seamless coordination with Roscosmos and maintain the collaborative efforts on the International Space Station, IISS. So what led to this reshuffling? Well, the Boeing Starliner, which was launched back in June for an 8-day test flight, ran into some technical issues, including helium leaks and thruster problems. To play it safe, NASA decided to keep Starliner's commander Barry Butch Wilmore and co-pilot Sunita Williams on the ISS longer than initially planned. Their mission, now extending to 262 days, necessitated their return on board the Crew Dragon instead. As a result, now set for its launch on September 24th, the Crew 9 flight will be captained by Nick Hague, an experienced astronaut who has spent 203 days in space during a previous mission. Hague originally was Cardman's co-pilot, but has since stepped up to the role of mission commander. Russian cosmonaut Alexander Gorbanov will join Hague as the mission specialist. But as he is not trained to pilot the Crew Dragon, the responsibility falls solely on Hague. This mission is not just about ferrying astronauts. It's also about ensuring the constant presence of both NASA and Russian crew members aboard the ISS. This collaborative arrangement aims to mitigate any potential risks, such as if an emergency requires one of the ferry ships to make an unplanned return to Earth. The decision for this crew reshuffle ultimately came from NASA's chief astronaut Joe Acaba, who acknowledged the difficulty and importance of the decision. Acaba expressed his confidence in the crew's ability to adapt to these last-minute changes, stating, "While we've changed crew before for a variety of reasons, downsizing crew for this flight was another tough decision to adjust to, given that the crew has trained as a crew of 4. I have the utmost confidence in all our crew." Interestingly, this shuffling is part of a larger, complex orchestration of upcoming missions to the ISS. For instance, the Russians are planning to send 2 cosmonauts along with NASA astronaut Donald Pettit to the ISS on September 11th. Then a trio of cosmonauts and one NASA astronaut will return to Earth on September 23rd, just one day before the Crew 9 launch. This sequence ensures a consistent rotation and presence of crew members on the ISS, further cementing the international collaboration that space exploration necessitates. Now let's turn our attention to outer space. The Event Horizon Telescope, or EHT team, has taken a giant leap forward in our understanding of black holes. They recently conducted successful tests aimed at improving the resolution of black hole images, a huge endeavor with the goal of seeing these enigmatic celestial giants more clearly than ever before. Collaborating with the Atacama Large Millimeter Submillimeter Array, known as ALMA, and several other facilities, the EHT team achieved an astonishing level of observational detail. Imagine being able to see a bottle cap on the moon from the Earth. That's the kind of precision we're talking about here. So how did they manage to do it? Well, the team worked at an incredibly high radio frequency of 354 gigahertz, which is way higher than what they've typically used. This allowed them to capture details as fine as 19 micro-arcseconds, the highest resolution ever achieved from the Earth's surface. Although there aren't any images from these tests yet, the initial observations showed strong light signals from the centers of distant galaxies, even using just a few antennas. With these new techniques, scientists believe they can sharpen the images of black holes by about 50% compared to previous observations. Remember those first groundbreaking images of M87's black hole in our own galaxy's Sagittarius A? They looked pretty amazing, but there was always room for improvement. Alexander Raymond from the Jet Propulsion Laboratory, who co-led the observation, mentioned that these new, sharper images will reveal more detailed properties around black holes. Some predicted, and perhaps some entirely unexpected. Shepard Dolman, the founding director of the EHT, made an interesting comparison. He said it's like moving from black and white to color vision. By observing the surroundings of black holes at different wavelengths, scientists aim to unravel the mysteries of how these cosmic giants attract and consume matter, and how they manage to launch powerful jets of particles across vast galactic distances. The EHT operates like an Earth-sized virtual radio telescope. Instead of building one colossal dish, it links multiple radio dishes around the globe, a technique called very long baseline interferometry. For this test, they expanded the wavelength range and refined the instrumentation to capture these higher resolution images. The ultimate goal is even more ambitious. They want to create high-fidelity movies of the event horizon, showing the behavior of materials swirling around these enormous gravitational wells. Imagine watching the incredibly dynamic environment around a black hole, almost in real time. There are plans to revisit the supermassive black holes in M87 and the Milky Way, with the enhanced imaging capabilities. These observations will offer a more precise measurement of the black holes' sizes, shapes, and even their spins. The EHT Consortium, comprising over 400 members, is geared up to push the boundaries, giving us the most detailed radio images of the mysterious entities that sit at the heart of most galaxies. It's a thrilling time for black hole research, and thanks to these advancements, we're closer than ever to peeling back the layers of these cosmic mysteries. Stay tuned for more revelations from the EHT team. And finally today, let's shift our focus to a land down under... No, not that one. The other smaller one. New Zealand's aerospace sector is experiencing rapid growth, with an ambitious goal of significantly impacting the global space industry. Like the rest of the world, New Zealand is striving to be part of the thriving space economy, which aims to reach a value of $1.8 trillion by 2035. However, this growth brings to light several pressing sustainability issues. One of the main challenges for the New Zealand Space Agency is balancing the drive for economic expansion with the urgent need for sustainable practices. As the global community becomes more aware of space debris and other environmental concerns, striking this balance has never been more crucial. New Zealand's aerospace activities took off following Rocket Lab USS decision to launch rockets from the Mahia Peninsula. This move led to the creation of the New Zealand Space Agency, a unit within the Ministry of Business, Innovation and Employment, which now regulates launch payloads and helps commercial ventures access funding. A key component of the country's aerospace strategy is its bilateral agreement with the United States, allowing the launch of American payloads on Rocket Lab's Electron vehicle. This cooperation is pivotal in reaching the target of generating 10 billion New Zealand dollars in annual revenue by 2030. However, this dual role as both regulator and promoter creates a conflict of interest, especially when it comes to sustainable development. Current budget constraints further complicate the situation, making it difficult for the space agency to fulfill both its economic and environmental responsibilities simultaneously. There is a clear need for transparency and defined roles to ensure sustainability doesn't fall by the wayside. Industries and companies are looking to the government for incentives to prioritize sustainability, such as monitoring emissions from launches. The space agency has made strides with policies on space debris removal, but critics argue these measures are not proactive enough given the growing number of market entrants. Minister for Space Judith Collins has stated that her office works with various environmental authorities and industry representatives to monitor and mitigate potential harms. However, these commitments lack quantifiable details, leaving a gap in accountability. To address these challenges, New Zealand needs clear guidelines and a balanced approach that involves both public and private sectors. Looking at other industries with strong sustainability initiatives could offer valuable insights into creating a more responsible aerospace sector. In summary, while New Zealand's aerospace sector is poised for significant growth, it must navigate the complex terrain of sustainability. Achieving this balance will require robust leadership, clear policies, and a collaborative approach to ensure that economic development does not come at the expense of our planet. That's it for today's episode of Astronomy Daily. Thank you for tuning in. Don't forget to visit our website at astronomydaily.io for the latest space and astronomy news, and sign up for our free daily newsletter. You can also catch up on all our back episodes and find us on social media by searching for Astro Daily Pod on Facebook, X, YouTube, and TikTok. This is Anna, signing off. Keep looking up.